Hi friends, this is Datta and today we will see second part of SQL query optimization is dealing with the queries those are having functions in where clause. In first part we saw the reading of execution plan and dealing with the all physical operators involved in execution plan. Okay, so in this part we will see how to deal with the queries which are already using functions in their where clause. Okay, it's generally advised or recommended that we should not use functions in where clause because it leads to index scan. Though we have indexes on the particular column, but it cannot search or it cannot use indexes optimistically if you use any functions in where clause. Similarly, if you use some casting, implicit or explicit casting in where clause, the same result will come and it will lead us into index scan. Okay, so we'll see the scenario practically. Over here I have one sample table I already created. I will just show you what is there in the table. Okay, so I'm just selecting, it is my test table. Okay, I will just star so this is test table, and throughout the session I will be going to use this test table for practice. Okay, so I will just select and you can see the data. So I will apply the where clause on this table where name equal to 1. Okay, so in this case you can see, I will just show you the execution plan of this query. Okay, in the execution plan you can see it is containing index scan, sorry, it's table scan. Okay, because there is no clustered index on the table, so it is going to table scan. Okay, so I will just add one primary key over here and it will again automatically add clustered index. Okay, so I'm just writing alter statement, alter table test1 add constraint pk underscore test1 primary key on column id. Okay, so I have added one primary key over here and I will again fire the same statement and we'll see the execution plan of the query. The execution plan will slightly change and you can see the table scan is converted into clustered index scan. Okay, you can see over here I'm just deleting the alter statement because it is no longer needed. I'm using over here where clause filtering on the column name, so you will see it's obvious that we have to add one non-clustered index on this column to achieve the more performance, because the where clause or the filter is on name column and there is no index currently available on that column, so it is doing the clustered index scan over there. And also you can see the suggestion given by the SQL query optimizer is you have to missing index and you have to create non-clustered index over here. So I will just create one non-clustered index for better performance. Okay, so first of all before doing everything, okay, I will just create one more copy of this table. Okay, select all into test2, okay, from test1, okay, because I want it for comparison of performance on query, because when I create multiple two copies of the same data, same number of columns and same number of rows, then I will show you the comparison between the two queries on the two table. Okay, so I'm just creating one more copy of this table. It will take some time. Okay, you can see over here the 5 million rows are there, okay, in this test2 table. So I will just show you what is there in test2 and what is there in test1. All the constants, primary key and indexes I will just show you within a single query as sp underscore help test1, and similarly I will create one more query as sp underscore help test1. So the both table should be same because we have created one more copy of the original. I'll show you first test1. So the test1 table, you can see the table name is test1, contains the 4 columns like id, name, gid and current date. Okay, it is having primary key, okay, pk underscore test1, and there is index, also clustered index, because it got created automatically while we create primary key. Okay, I will just have same query on test2 and you will see the same number of columns over here, like same number of columns as id, name, gid, current date. Just one thing is missing over here is it don't have the primary key. So I will create a primary key on test2 also. Okay, so the both table will be in sync and the difference will be in the final query. So I will show you the difference and how to deal with the queries having from clause with where, with function in where clause. Okay, so I will again write one alter statement, alter table test2, add constraint pk underscore test2 as a primary key on id. Okay, you can see we have created primary key on this also, means now the test1 and test2 are both tables are in sync. So I will fire the same query on both table and I will show you what is the difference. Okay, so you can see over here the cost of both queries is 50-50%. This is the cost of first query. Over here it is 50% and second query also 50%, means there is no difference in performance. Okay, I will use the function in where clause as it is stated. Okay, so you will see, so you will say that if you are using filtering on name column, then you should have at least one non-clustered index on column name. So I will create one non-clustered index on each table as create non-clustered clustered index as index name ix underscore test1, okay, on name. So I am giving the meaningful name for the index, and on I will give the table name test1, and I will give specify the column over here. Okay. I will create again same index on second table as test2. Okay, so now both tables are in sync. Again I will show you the cost comparison between two tables. Sorry, I think we have misplaced the test1 table in both places, but I will now correct it, and I will show you the both queries are running with equal cost 50-50%. So you will see this upper query is also having 50% cost and lower query is also having 50% cost. You can see in full screen the execution plan is exactly the same over here. Okay, it applies lookup and the index seek over here and name. Okay, so instead of star I will put over here ID. Okay, I will put over here ID, and I will show you there is no need of top operator. I will fire both queries and I will show you the sharing of cost among between these two queries. So again you can see over here the index seek in both places it is appearing index seek. Over here also it is index seek, means now no longer index scan is happening over here. But the main question is again unanswered, is how to use function in where clause. Okay, so I will use over here function as substring. Okay, many time it is recommended or always recommended that don't use any function in where clause, but sometimes it is the way of logic. Okay, sometimes for the logic of the query we need to use functions in where clause because we cannot avoid it. Okay, so in this case I'm just applying over here the substring function on the column name, and we'll see what happens. Okay, now up to now we already saw that index seek was happening and no longer index scan was there. So I will just show you again index seek at both places, but once I converted simple where clause into the function, okay, I have used the function in where clause for the filtering, then index seek will convert into index scan and it is more costly. Sorry, I think something happened. Okay, it's correct. So we are selecting all those records who are starting name with one, ONE. Okay, so substring means it will get part of the name from first character for next three character. Okay, so we'll count first character to next three characters, as if it is containing ONE then only it should give us result. So it is giving us result over here in both places. It is giving us more on 1 million rows. Over here also same. Okay, I will show you that both queries again performing same with 50-50 costing. Okay, so I will now answer the question how to deal with this query. So first thing is I will create one calculated column on test2, and test1 will be remain as it is. Okay, so I will alter table test1, add new call as its column name. For calculated column I'm giving as a new call, and I will not specify any data type because it's no longer needed. I'll just specify the function within that with the value for that calculated column. Okay, means at the time of query fire it's better to have already calculated column instead of the calculation at the time of query execution. Okay, so this function will fire substring query function. This will where clause will fire substring function at the time of query execution, and it will go for row by row query index scanning. Okay, so instead of that I'm just creating new column as a calculated column with the same function. Okay, so I will store the result of this function into this new column. Okay, so I have created new calculated column and test1 table. Again you can see I will fire these both queries and we'll see if there is any difference, if we can see any difference. Okay, we can see over here as of now there is no any difference. We have created one calculated column, still there is no difference in costing of both queries. Okay, so one more thing, I will go and create one non-clustered index on column new call. Okay, so create non-clustered index ix underscore test1 underscore new call on. This is syntax for creating non-clustered index on. I will specify over here table name test1. I will specify column name in bracket as new call, and I will show you the result after creating this index on calculated column. Now I have created a non-clustered index on calculated column, and we'll see what is the result of these two queries over here. You can see the upper query is having only 6% of costing and lower query is having 94% costing, because upper query is having index seek, okay, and lower query is having index scan. Okay, so you can see the difference between cost of query and difference between the execution plan, and up to now I think you should get answer the why and how to deal with the queries having the functions in their where clause. Okay, so we know that it's always recommended not to use indexes, not to use any function in where clause, but sometimes it is needed and it is a need of the logic of the query. So we can deal with that situation by adding one calculated column over here in the original table and then applying non-clustered index on that calculated column. So that's all for today, and please see my next video for another next part of the SQL query optimization technique. If you like my videos, please subscribe my channel, please like and share my videos on your social media accounts. Thanks for watching this video. Bye bye.